we're going to look at some different fractions now. So I want you to have a look at these fractions here at the top and think about how these compare with what you've been dealing with so far. X squared, x here, x cubed, x squared. So all of these things here, we would call these all improper fractions. In other words, the degree of the power, okay, in the numerator, okay, so for the highest power is greater than or is the same for than the denominator, okay. And in this situation, we can't use partial fractions yet. Okay, so we need to divide, and we're going to use long division from year 1 to rewrite these, and later we'll rewrite them and then turn them into partial fractions too. So let's have a look at a question. Question that we're going to do is this one here. So if x squared plus 5x minus 9 over x plus 2 equals this, what would the numbers be? So we're going to say then x squared and all this divided by x plus 2. Perhaps you can see already how, because you have an x squared and an x to the power of 1, you would get an x if you divided. Yeah. You might also notice that this is the same that we're dividing by, and there's a reason for this. So let's look at this with some long division. So I'm going to take x squared plus 5x minus 9, and I'm going to divide the whole thing by x plus 2. So the process is like this. You compare this one, and you say how many times does it fit in? It fits in x times. You write the x up here outside, okay, just lining things up. So if you did have x times x, you would have x squared. That's where this came from in the first place. But you also need to think about the 2, so 2 times x would be 2x. Each line here you subtract. So x squared minus x squared, that would disappear. 5x minus 2x, yes, is 3x. And then minus 9 just carries on down. This is just year 1 revision for you. Same process again. Now I've got 3x and I'm still dividing by the same thing. How many times does x fit into 3x? It fits in a positive 3 times. So that goes up there. Line up the numbers. 3 times x would give you 3x. 3 times 2 would give you 6. You subtract every line. 3x minus 3x disappears. Minus 9 minus positive 6. It's minus 15. So we've actually answered the question. We just need to put this in the right form now. So if I do all of this quadratic here that I've rewritten, and I divide that by x plus 2, which is what a fraction means ultimately, it means divide. I can put it into this form. So the answer will give me this many x's, this many for the constant, and then there'll still be some remainder that still needs to be divided. So for the x, well, that's just this bit up here. Okay, it's 1x, isn't it? So that's this bit here. So a equals 1. Yeah, 1x. For the b, the number part without an x, that's the 3. So b is equal to 3. So 1x, in fact I don't like 1x, I'm going to get rid of that. Let's just say x. X plus 3. And then there's some number still that's being divided. It's not finished. Well, that's this, isn't it? It hasn't cleanly divided. So this is left over. It's the remainder. It's still being divided. So that 15, minus 15 really, is still being divided by x plus 2. The answer is not 15 though, okay? Because if you compare, there's a plus sign in the form that they want it. So C is minus 15. So this is what we need to do. What would the next step be? Well, if you're thinking ahead, the next step would be for the last part here to break this up perhaps into partial fractions if the denominator is more complicated.